In our next section here, we're going to discuss the TCP Intercept feature before we get to content-based access control or the zone-based policy firewall. And we'll see the reason why is that TCP Intercept can be configured as a standalone feature. It can also be a feature that's integrated with CBAC or zone firewall. And then ultimately when we get to the ASA, this would be the TCP normalization feature that we can configure under the modular policy framework or the MPF inspections. Now, what TCP Intercept is a feature that it is designed to prevent TCP SYN flood attacks against devices in the infrastructure. Now, we talked about how the basic TCP three-way handshake works, that the initiating client is going to send the SYN to the TCP server. TCP server replies back with SYN ACK. Then the client is supposed to completely open the session by replying with a final acknowledgement. Now, in the SYN attack, the client sends the SYN, the server responds back with the SYN ACK, but then the client does not fully open the session by sending the final acknowledgement. And the basic theory of the attack is that there's only a certain number of TCP sockets that the server can bind, and once the TCP stack runs out of those, it's not able to run the web service or run whatever TCP application that it is using. Now, these portions of the handshake that are not completed, this is what we refer to as either a half-open session or an embryonic session. So we'll see in the case of ASA, it calls these the embryonic, but it's talking about the same thing. And the reason that this is a problem, again, because the server's TCP stack can only support a certain number of sockets or a concurrent number of sessions open. Now, in order to fix this problem, we could, of course, just filter TCP in general, but then that's going to break the application, so it doesn't really, solve the problem. What we can do instead is to try to watch the traffic as it's going from the clients to the server, and then if there are too many half-open sessions, we can either start to selectively close them, or we can use the router as a proxy in the middle between the client and the server. So two different ways we can do this. What we call the intercept mode, where the router is proxying for the connections to the server. So the router is going to listen for the TCP SYN. It's going to reply back with its own SYN ACK, and then finally open the session fully to the server once the three-way handshake is complete. Now, the more common mode to run this in is the watch mode, where the router is just passively monitoring the session establishment. Then it's going to send a TCP reset to the server, basically spoofing the source, if the connection does not complete in time. Now, the reason that we would want to run the watch mode and not the intercept mode is that we're basically taking the SYN DOS attack on the server and moving it to the router if we are running in intercept mode. And generally, the server CPU is going to be more powerful than the router's is for that particular application. So it's not really solving the problem. It's just moving the problem from the server onto the router. So we don't want the router inline for the traffic. We just want it to monitor the traffic flow, which is going to be the watch mode. And we'll see that this is the one that is applied in CBAC and in the zone-based policy firewall. But in the case of the original implementation of this, TCP Intercept, we could apply them either way, under either the intercept mode or the watch mode. Now, to apply this from a configuration point of view, the first thing that we need to do is to define what type of traffic are we watching. So normally this is going to be like our web servers that we want to protect. So we create an access list and then reference this from the IPTCP intercept command in global. The default intercept mode is intercept. So if we did not want the router to actually proxy for the connections just to watch them, we would change the intercept mode to watch. And we can also change what are the particular timers that the router is using. So how long do we take before the session establishes, and then if it doesn't establish within this period of time, we're going to send the reset. And we also have these thresholds. So what is considered too many incomplete sessions? So this would be the high threshold. We could say 1 minute limits or a per initiating host number of sessions. So this is going to determine when does the feature actually start to enforce the application threshold. So if I say that my absolute high threshold is 1,000, once we go above 1,000 half-open sessions, then the router starts to aggressively drop them. So it starts sending resets back to the server, or in the case of the intercept mode, it just starts to throw those away. So let's take a look at this within the scope of our particular topology here, where we're going to be having router 3 running the TCP Intercept feature. We're going to say that router 2 is essentially the victim of the attack, and the test PC here is the attacker. So the test PC is going to be generating SYN packets to router 2. Router 2 is going to try to reply back with the SYN ACK, or if it's for a port that's not open, it's going to say reset ACK, so saying I don't have that particular port open. But then once they get back to the attacker, if the attacker does not reply back with the third portion of the handshake, so normally it's SYN, then SYN ACK or reset, then if the session is going to completely open, third portion is going to be the final acknowledgement. Now, since I don't have an application to actually generate the SYN attack on the test PC, the way that I'm going to be doing this here is with basically doing a port scan, which is with Nmap. So you'll see if you're using our particular rack rentals for any of these topics, there's a bunch of applications that are on the test PCs that you can use for playing around with these different features and then actually looking at the result of them. So from here, I'm going to say that router 2 is the target, and we're going to do a full scan. Let's say every particular port. So intent scan all TCP ports. Now, if we look at router 2 and look at the show proc CPU, once the application, so right now it's trying to do DNS resolution, once it actually goes into starting to do the scan, we'll see that this is going to start to spike the router CPU because it has to reply back to all of these individual requests. So we could see for the past 5 seconds, 32%. So as a longer term average, if we were to look at the show proc CPU sorted, or the show proc CPU history, the particular process that is going to be causing all of the utilization is the IP input process, and this is because of the interrupts, because this traffic is being process switched. Now, we'll talk about this later when we get to attack mitigation, how we can stop the infrastructure from having these problems. So things like control plane policing and control plane protection, that you normally don't want your end host to be able to send traffic to the routers themselves. But we'll hold off on that until we get to more specifics in our attacks. But we could see just by doing the port scan, the router CPU is starting to grow. It was basically at 0% before, and now it is now it's a little bit higher. Now, if we look at router 3 and look at the show access lists, we still have our reflexive access list configured from previously. And we see that it's opening all of these holes in the firewall. This is basically the port scan that's coming from the Nmap application. And we can see it's kind of doing like random jumping around for the ports. And we can see these are basically just one matches. It's sending a SYN to see which one is it going to get a SYN ACK backwards for, and that's going to tell us what particular ports are open on the destination device, which in this case is router 2. So if we look at the application, it should tell us a few things are open, like Telnet is open, port 23, port 80 is open because we're running the web service. And then some other minor random ports, 9002, 6002, etc. Okay, so in order to look at the final result of this, what I'm going to do on router 2 is to say that as the traffic returns I'm going to put an outbound ACL on that interface that essentially says to deny any TCP traffic as it returns. So this means that router 2 is going to get the SYN, but then when it goes to reply back with the SYN ACK, it's going to be dropped. So router 3 is never going to receive back in the, or actually I'm going to apply this as an inbound ACL, excuse me, because the outbound ACL will not affect our locally generated traffic. But this means that router 3 is never going to receive the SYN ACK back inbound, and then the TCP intercept process is going to start dropping the sessions. So from a minimum configuration point of view on router 3, we would simply say that we want to run TCP intercept, IP TCP intercept, and we define what are the particular hosts that we want to protect. So we could say specifically router 2's loopback, or whatever our web servers are, whatever the application servers are, or we could be more general. If we do show access list 100, let's say access list 100 is just to permit any TCP traffic. Okay, and this is only for TCP. It's not going to protect against any type of UDP flood attacks. Hence the name, TCP Intercept. So IP TCP Intercept list 100. And this is simply configured globally. From a verification point of view, if we look at the show IP TCP Intercept, or actually show TCP Intercept connections and the statistics, the connections are going to be the ones that router 3 is proxying for if we are running in intercept mode. The statistics are just in general, how many half-open sessions do we have, how many incomplete sessions do we have, how many requests do we have per minute, and then this will tell us, are we actually starting to get to our aggressive thresholds. So on the server, let's go ahead and run this scan again. And we can see now these are the ones that router 2 is responding back with the SYN. And we can see now the feature is starting to kick in. So it's saying I'm going into my aggressive thresholds because I exceeded 1100 for a 1-minute count, which essentially is the default timers here. So if we look at the show IP TCP or show TCP intercept statistics, right now there's 1100 incomplete sessions. And then we're going to start to aggressively drop these. Now, if we again, actually, let's look at router 3 and look at the show proc CPU on it. We can see now router 3 is at almost 100% utilization, and one of the side effects of that was that we lost our OSPF adjacency to router 1. So as I mentioned, if we're running TCP intercept in intercept mode, which is the default, you're basically taking the DOS attack that is going to the application and then moving that to the router, because the router is now trying to proxy for each of those connections. And if the traffic is local to the router, it means that it's process switched, and ultimately it's going to spike the CPU to generate a really high value. And we can see this is only one machine that is doing a port scan just to one destination. You can imagine if it was some sort of distributed type of traffic flow that was coming from the devices. So let's go ahead and change this config on router 3. If we show runs section intercept, and we'll say that the IP TCP intercept mode is to watch the connections. And we can see here from the application's point of view, it thinks that all of these ports are now open, which is because it wasn't actually router 2 that was responding, it was router 3 that was responding as proxy. Because when we're in the intercept mode, basically any TCP traffic that's coming in, router 3 is responding with SYN-ACK. Then once those completely open, it sends the request to the actual TCP server and gets the response back in. So you generally do want to do this type of protection where you're watching the traffic, whether it's with CBAC or whether it's with the zone firewall or the ASA, to limit the number of concurrent incomplete sessions. But you want to make sure that you're not offloading the problem onto the router itself, which is the intercept mode. And intercept mode is not supported in the newer versions of this, either CBAC or the zone firewall. So if we try this again from the end host here, let's cancel this scan. Actually, let me restart this here. So we're scanning 150.1.2.2, and let's say all TCP ports. And let's look at router 3 while it is doing this. Let's say show TCP intercept connections and show TCP intercept statistics. We should see here shortly that these numbers start to grow. And if we were to go to router 2, like I said, we're going to configure an inbound ACL that is denying the TCP flows. So essentially this is going to stop router 2 from being able to respond with the SYN-ACK to the originator, to the test PC, which from router 3's perspective, it's going to see it as a SYN attack because it gets the first portion of the handshake, but not the ultimate acknowledgement. So on router 2, let's say access list 100 deny TCP any, access list 100 permit IP any, and then this is applied on gig 00 inbound. And we could see these replies here were also debugging IP ICMP. If we show debug, these are all essentially the drops that are coming from that access list. So if we show access list, we can see this counter is going to start to go up. That's the scan that the end host is running. Now again, from 3's perspective, it should start to see these as incomplete sessions. And then eventually go into its aggressive mode. Now, it ultimately depends on what is the application, or how quickly is the application scanning. So by default, it's running a stealth scan, which is like it skips around ports and it does it at a random interval. But we'll see as we go to more application level inspections, when we get to doing the TCP normalization in CBAC and zone firewall and the ASA and also the IPS sensor, they're going to have different results that they respond with. They should be able to ideally detect these type of scans and these type of attacks, and then do things like shun the host or block the connection inline, or drop the connection from the firewall's filtering point of view. Now, from a documentation point of view, if we go back to the main iOS documentation, and then under security, I'm not 100% sure if this is documented in the newer versions anymore. This should be securing the data plane. And let's actually go back to an older release. Let's go to, let's say 12.4 mainline. So from the main documentation page, products, iOS, Cisco iOS 12.4 mainline, configuration guides, secure, I want to say this is securing the data plane. It's not listed under here. Let's actually do what I was mentioning previously with the documentation. So the problem is I'm trying to find where's TCP Intercept documented, but it's not where I thought it was, which should be under securing the data plane. So now we're going to work backwards from this because we already know what the command is, we just don't know what the specific section of the documentation is. So we can do this by going to, instead of the configuration guides, we're going to go to the release information and the master index, and the master index for commands. So we know the command is IP TCP Intercept, so it should be in here. And let's search for TCP. So IP inspect TCP, IP TCP intercept list. So it says security, iOS security command reference. So it should be under that section, but it looks like in this particular release, it's not under the configuration guide. But you definitely, again, want to make sure that you spend some time reading through the command reference so you know what are the features of the particular protocol. You don't need to memorize what are all the options and what are the syntax, what is the specific syntax for it. You just need to know that the router or the ASA or whatever particular device has that feature available to you. So within the scope of the lab exam, if they asked you a question about preventing SYN attacks on the router and the router is not running CBAC or a zone firewall, and maybe they're asking you also to do some customization, as long as you know that the TCP intercept feature exists and then where to find it here in the documentation. So like if I wanted to change what's the timeout that I send a reset after the finish exchange or the FIN comes from the server. And we could see by default you wait 5 seconds before we're doing that. So most of these are self-explanatory once you look at the documentation. But again, the problem is you cannot search the documentation in the exam. You have to manually know where to navigate to these. And any issues like this where the document is supposed to be there, but for some reason, like maybe the web page was mislinked on that particular release, you need to know how can you work backwards from the master index in order to get back to the particular feature. Okay, there's a question on the exam. Are all versions of the iOS documentation going to be available? I'm not 100% sure exactly which pages are and are not. In general, you can assume that the command reference and the configuration guide, along with the master index, should be available for whatever relevant release that you need. So it might be there for 15.2t, but not for 11.3 or 12.1 mainline, because those pages probably aren't relevant anymore. So in general, if you pick the higher releases, it should include the documentation for the older one. So if 15.1t is not there, go to 15.2. If 15.2 is not there, go to 15.3, because ideally the newer one should be just overall encompassing for the older features as well. So really the main takeaway for this is that you don't want the router to run in intercept mode, because you're basically taking the DOS attack from the application and then offloading that onto the router.